us try these examples. The question asks us to determine the dy dx for these equations. From the equation here, we know that it is an implicit function. You are unable to separate the x and y to the left and to the right of the equations. And then the second part of the questions asks you to determine the dy dx when x is equals to 1 and y is equals to 2. In order to differentiate these equations, you will have to differentiate every single term in the equations. There are constants. You know that differentiating a constant, you will get 0. There are terms with single functions. You can differentiate it directly. And there are a term with two functions that appear in the product conditions. With that, you will need to use the product rule for you to solve it. Let u equals to 2x and y power of 3 as the v. Differentiate the u and v to the functions of x. You will get these two equations. Differentiating the y functions, you need to incorporate dy per dx. Use the product rule. U dv dx, v du dx. Rearrange the equations, you get this. With that, you are able to differentiate the terms one by one. Here, rearrange the equations to have dy dx on one side and the rest on the other side. Group the dy dx, move it to the opposite side, and you may simplify the equations. Now you have obtained dy dx here. You are asked to determine dy dx when x is equals to 1 and y equals to 2. Substitute the relevant value into the equation here. You will get dy dx equals to -6. Let us try one more example. For this, you are asked to find the gradient of the tangent drawn at the circle equation here at point x equals to 2. You know that you need to determine the gradient. That means it will be dy dx. By looking at the function here, because the y have the power of 2, it is difficult to separate y and x in both sides. That means this is an implicit function. You will need to differentiate every single term in the function here. Whenever you encounter differentiations of y, you will need to incorporate dy dx. The derived equations is here. Separate dy dx on one side while the rest on the other side. Group them. Rearrange the equations. This can further be simplified into these equations. Now you have obtained the dy dx, which represent the gradient of the function. From the equation here, there are x and y. However, the questions only give you the x. You will need to find the y. To do so, you will need to substitute x into the equations. Solve the equations and you realize that there will be 2y, -1 and 3. That means at the point x equals to 2, there will be 2 points. When x is equal to 2, the y can appear to be -1 or 3. Substitute x equals to 2 and y equals to -1 into the equation here. You get 1/2. And substitute the x equals to 2, y equals to 3 into the equation here. You will get -1/2.